Next problem. We are on a farm. We have 45 acres of land total, and we can plant pumpkins or strawberries. So if we plant one pumpkin acre, that gives us $200 of profit. One strawberry acre gives us $300 of profit. And we're also limited by labor and fertilizer. So pumpkin requires 3 workers per acre and 2 tons of fertilizer per acre. Strawberry requires 2 workers per acre and 4 tons of fertilizer per acre. We've got 100 volunteer workers, that's great, we don't have to pay them, available to us, and 120 tons of fertilizer available to us. Okay, so a lot of things limiting. We've got total acres of land, labor might be limiting, fertilizer might be limiting. So let's just get a sense of how limiting everything is. Let's think about if we only plant pumpkin. Okay, so we could use all 45 acres of land to plant pumpkin, except we probably can't because we have 100 workers. We need 3 workers per acre, so we can plant at most 33 acres of pumpkin, limited by labor. We got lots of fertilizer. We could have planted 60 acres of pumpkin with the fertilizer. Okay, so only pumpkin. The most we can plant is 33 acres, which, by the way, gives us 33 times 200 is $6,600 in profit. That's if we only planted pumpkin. We're wasting a lot of acres, we're wasting fertilizer. Probably not the greatest plan. What about only strawberry? Let's see. We got lots of workers. We could have planted 50 acres of strawberry with workers. We only have 45 acres. But we don't have much fertilizer. We can only plant 120 divided by 4, which is 30 acres. So we're limited by fertilizer here. And then that would give us 30 times 300, $9,000 profit. Okay, so that's better. But we're still wasting some workers. We got lots of empty acres. Maybe we can do better than that. Okay, so let's let x be be number of acres of pumpkin. Let y be number of acres of strawberry. Okay. So we'll show 3 methods to optimize profit. All of them will be wrong or missing something. A few of them will get you, all of them will get you the right answer actually. But none of them will be complete. Part of your homework is going to be to explain why these methods aren't quite right. Okay, so method 1. And by the way, we're maximizing, we'll use this in all the methods, we're maximizing 200x plus 300y, right? That's our total profit. And we're going to call this 100 times 2x plus 3y. That's just factoring out 100. And we'll call this 100z. So that's let z equal 2x plus 3y. Okay, we want to maximize that. So in our first method, let's just write some equations, even though they're inequalities. And we'll do it just like the lifeboat problem. We'll just pretend they're equations and solve. Okay, so we got an equation for labor. 3 times the number of pumpkin acres plus 2 times the number of strawberry acres has to be 100. It's really less than or equal to 100, but we're going to pretend it's 100. And then we've got 2x plus 4y. This is for fertilizer. And really less than or equal to 120, but we're going to say 120. If you hear it snoring, that's my dog. Okay, equation 1, equation 2. Equation 2 divided by 2, because we have a common factor of 2, so we'll make it smaller. And in fact, this also helps us eliminate. We're going to take equation 1 minus equation 3. and we get 2x, the two y's cancel, equals 100 minus 60 is 40, so x must be 20. We'll sub that into 3. 20 plus 2y is 60. 2y, can we see this? 2y is 40, so y, apologize for that, y is also 20. Okay, and then let's just check what that gave us. First of all, so 20 acres of pumpkin, 20 acres of strawberry. That is, in fact, less than or equal to 45 acres. We didn't really have an equation for that, but we do check that we have enough space. And then our profit is 100 times 2 times the pumpkin acres plus 3 times the strawberry acres. That's that expression there that I'm subbing into. And that is going to be $10,000. Better than our $9,000 from only strawberry. So that's promising. Yeah, looks like the answer. We can get $10,000 in profit. There is something wrong with it. You'll describe that in the homework. Okay, method 2. We're just going to do the exact same thing, except maybe it was kind of sketchy to put equations. So we're just going to do it with inequalities. So let's see, 3x plus 2y, really it was less than or equal to 100. You can't use more than your workers, but you probably aren't using all of them. 2x plus 4y less than or equal to, again, you can't use more than your fertilizer. All right, inequality 1, inequality 2, and we're just going to do the exact same thing. Inequality 2 divided by 2, x plus 2y less than or equal to 60. That's inequality 3. Inequality 1 minus inequality 3, 2x less than or equal to 40, x less than or equal to 20, and sub that back into 3, 20 plus 2y less than or equal to 60, 2y less than or equal to 40, y is less than or equal to 20. And why would we take less than or equal? We want to make as much money as possible, so we'll take the maximum. 20 plus 20 is still less than or equal to 45. We've got a good number of acres, so our profit is still, when we take the maximum, same as method 1, $10,000. What is wrong with this method? Let's do one more method. So, let's look at these inequalities differently. Method 3. And we're going to remember that we had this variable z. Z was 2x plus 3y. And we're maximizing 100z, which basically means we're maximizing z. If we maximize z, we maximize 100z. Okay, let's write down these inequalities. Regardless of whether method 2 was right, these inequalities are certainly right. We got that from the information in the problem. Inequality 1, inequality 2. And let's look at inequality 1. Let's multiply that by 3. Certainly allowed to do, no, sorry. Let's multiply that by 2. Okay, we're certainly allowed to do that. 2 is a positive number. Okay, so we get 6x plus 4y is less than or equal to 200. Okay, and we're just going to try to create z's here. So 6x plus 9y is 3 times z. So I'm just going to create that, and to get back to 4y, I have to subtract off 5y. So I haven't changed anything. Okay, so this is now 3z minus 5y is less than or equal to 200. That is equivalent to inequality 1. We multiplied it by 2 and subbed in z basically where we could. Let's try to do the same thing to inequality 2. Here we don't have to multiply by anything. I have a 2x plus 4y. I want 2x plus 3y, so I'm just going to say that's z, and then I have an extra y to get back up to my 4y is less than or equal to 120. We'll call that inequality 4. Okay, Well, now we have z's and y's, and we want z's. So let's try to eliminate the y's. So I'm going to take inequality 4 times 5. So that's 5z plus 5y less than or equal to, that's 600, is 120 times 5. Call that inequality 5. And then we're going to add inequality 3 to inequality 5. We get 8z, the 5y's cancel, less than or equal to 800, z less than or equal to 100. So the maximum value of z is 100, so then our profit is 100, z is less than or equal to 10,000 again. Sorry, you could not see that. Okay, there we go. So, couldn't see this part, but we multiplied inequality 4 by 5, added 3 and 5, the y's canceled, so we got 8z less than or equal to 800. Z was less than or equal to 100. That gave us a profit of 100z less than or equal to 10,000. Okay, 3 ways of solving this problem all gave us a profit of 10,000. All of them are slightly missing something. Maybe if you combined them, you would be able to get a full solution. Maybe not. But your homework assignment will be to explain what is missing from each one or what is wrong in each one.